So, an outdoor club held a car wash to raise money for cancer research. They washed cars for $5 each and vans for $7 each. They washed 45 vehicles and earned $240. How much of each type of vehicle did they wash? So what I've done is I've done the first step, and we are reading the problem. So we don't want to be scared of the word problem, we just want to read what the problem says. So I read the problem carefully. Now the thing about word problems is we need to determine what our unknowns are. So if we go back and we look at what our unknowns are in this case, often the last sentence in the word problem will tell you what the unknowns are. Our unknowns are how many types of vehicles of each. If we look at our problem carefully, they've washed what kind of vehicles? They washed cars and they washed vans. So that's what we're going to define our unknowns as, cars and vans. Now you can choose whatever variable you like. I'm just going to use, for simplicity's sake, X. Now when we're defining our variables, we want to be as specific as possible. So let's say, let's let X equal, and we don't just want to say cars. We want to say specifically the number of cars. And we're going to be even more specific and say the number of cars washed. Now, you'll find out later on why it's very important to make sure that you have defined your variables. If X is the number of cars washed, we know right away that Y has to be the number of vans washed. I haven't done any math. I haven't even tried to think about solving this problem yet. All I've done is defined our unknowns. So here is step one. Read the problem carefully, determine what the unknowns are, and assign variables for them. So after we've done that, now we're going to do step two. Now by far step two is the most tricky part of a word problem. So what we want to do is we want to use our defined unknowns to determine the set of equations with the rest of the info in the word problem. Now what does that mean? Well, if we look at our word problem, we were given more information. We were given this information right here. We were told that $5 was earned for each car that was washed. We were also told that vans make $7 each. We were told 45 vehicles in total were washed, and we are also told how much money was earned. So we want to write our system of equations using our two unknowns. Now often, if we have defined our unknowns properly, the first equation is going to be very easy to determine. Because we have defined it in terms of number of cars and number of vans, right off the bat we know if we add the number of cars plus the number of vans, it's going to have to equal the total number of vehicles. And the total number of vehicles in this case is 45. So that's the easy one. Now we have to determine a system of equations that deals with this piece of information, 243 and our dollars. We know that for every car that gets washed, they earn $5. So if they washed 5 cars, they would earn $25. If you washed 10 cars, you'd earn $50. If we washed X cars, we're going to get 5X. 5 times X. So whatever that X value is, we multiply it by 5 and we determine that's how much money you'd get from washing cars. And the same goes for vans. Only this time a little bit bigger, so we're going to get 7Y. Now, what does that whole thing equal? Well, if we take the amount of money you earn from washing cars and the amount of money you earn from washing vans and add them together, the question tells us that we need to have $243. And lo and behold, look at what we have. We have two equations, two unknowns. We can now solve our system of equations.
But for right now, we're not going to solve the system of equation. We're going to worry about that a little bit later.
So let's look at a classic example here of flight and going a distance. So we have a small plane, took 3 hours to fly 360 kilometers from Ottawa to Halifax with a tailwind. On a return trip flying into the wind, the plane took 4 hours. Find the wind speed and the speed of the plane in still air. So we do that first step. And the first step was reading the word problem and defining our unknown variables. Again, let's look to that last sentence, and it says, find the wind speed and the speed of the plane in still air. There's our unknowns. We can define our variables. So let's just say, let's let x equal, let's just say the speed of the plane in still air. And we're going to let y equal the wind speed. So we have our variables defined. Now, when we're doing a problem like this, with distance and speed and time, the easiest way to solve a problem like this is to draw ourselves a little chart. So what we're going to do is we're going to organize our data in a chart. So let's just draw ourselves a chart here, and we're going to draw a chart with 3 columns. There's one column, there's a second column, and there's a third column. Because what we're going to do is we're going to take this information, we're going to gather the information from our word problem. And we know we're dealing with speed, distance, and time. And let's recall that speed is distance over time. So we have 2 scenarios here. We have Ottawa to Halifax and back. Halifax to Ottawa. Now, if we were going Ottawa to Halifax, it tells you have a tailwind. If we have a tailwind, we have something blowing on the back of the plane, on the tail, it's going to increase the speed of the plane. So our speed from Ottawa to Halifax is going to be the speed of our plane, x, plus that wind speed, y. And if you're flying back into the wind, it's going to slow down that plane. So we're going to have x minus y. We're assuming that the wind is the same both ways. And what's the distance? Well, let's look at the problem there. We know the distance is 960 going both ways. And now, once we have 2 columns filled, we want to fill up the 3rd column using our equation. So we want to use this equation and solve it for time, because time is what we don't know. We don't know the times here. Of course, we were told the times, but we're going to use those later on. So we want to fill in the time using this equation. So what we have to do first is we have to solve this for time. So if we just cross multiply, and we should be able to do this in our head, time is going to be distance over speed. What's the time from Ottawa to Halifax? Well, it's the distance, 960, divided by the speed, x plus y. And the same thing goes 960 over x minus y. Now we can write our system of equations, because we know that the time from Ottawa to Halifax is 3 hours. And we know the time from Halifax to Ottawa is 4 hours. We can now write our system of equations. So what does our system of equations look like? Well, we take that time from Ottawa to Halifax, which is 960 over x plus y, and that has to equal the time from Ottawa to Halifax was 3 hours. And our other equation, 960 over x minus y, and that's going to equal 4 hours. So now we have 2 equations, 2 unknowns. We can solve this system of equations.